remember when we did this before, we had you, I should start over. When we are looking at this particular situation, this is a series because we are summing things. This is the summation notation way to write it. And there's another way to write it as well. I could have started and done this and written it this way. Do you agree? Yeah. There's two different ways. Oh, it should stop at a certain number. Oh, hang on. I think it's 112. All right, so I could have written it this way. And if you remember last class, I had you take it written out in sequence form and write it into summation notation. Do you remember how we did that last time? Okay, we used the formulas to be able to do that. How do I know whether it's arithmetic or geometric in this case? Most of you didn't even care. Most of you went straight to the calculator and said, well, I know the summation formula and the place on my calculator to do that. Is that what you guys did? Perfectly fine. Tell me what you got when you did that. You plugged it in and you got 2,140? Okay. Let me show you another way if you wanted to use the summation formula to be able to do that. How did I get these numbers, -5, -2, 1? Where'd they come from? What did I tell you that this summation notation does? What do the 1 and the 40 have anything to do with? What do these have anything to do with? What do I do with the 1? That's the first number. That's the first term. So I'm going to plug in a 1 into my formula. So the first term is simply going to be 3 times 1 minus 8. Wasn't that -5? Yeah. Okay. That's where the -5 came from. If I want to find the second term, don't I have 3 times 2 minus 8? Isn't that -2? Right? And I realized I wrote it as a sequence. Shouldn't I write it as a series by putting plus signs here? Right? We're summing it, aren't we? Okay. And then how do I get the 112? Well, it's the 40th term. So 3 times 40, which is 120 minus 8, should be 112. Okay. Well, what kind of a sequence is this? Or what kind of a series is this? And since we are talking about series, we're adding these numbers. What kind of a series is it? Arithmetic or geometric? Arithmetic. What is the common difference? What am I adding or subtracting to get to the next term? 3. Okay? So I know that it's arithmetic. And I know that D is 3. Well, you have a formula for this as well, in case you need it, that the sum of the first 40 terms in an arithmetic sequence, or series, sorry, is down here. We have 40 divided by 2, the first term, plus the last term. Let's see if we don't get the same answer as 2,140. So if we type it in, 40 divided by 2 times -5 plus 112. And I did get 2,140. So the sum formula works just like the calculator, except for we had this in summation notation first, didn't we? As opposed to doing it here. No big thing. When you have arithmetic sequences in series, you have a set of formulas to use. And we've been using those, or the ones on the left-hand side. We're going to spend today looking at the geometric side. Okay, so the other side. And what's the difference between arithmetic and geometric, by the way? Arithmetic is what? You're adding or subtracting the same number. You have a common difference. What is geometric? You're multiplying by the same number. Okay, so let's kind of refresh our memory here. And let's write, convergent and divergent. Whew. It's not a movie, okay? So I know Divergent. It's one of my favorite movies. We watch it all the time. Isn't there a new one coming out soon? Insurgent. When does it come out? This summer? It's already out? When did that come out? I'm so behind the times. You're a little awkward, Miss Mackert, because you're really out of touch with reality. Okay. Anyway, has anyone seen it yet? Is it good? All right, fine. Well, I guess I know what I'm doing this weekend. All right, here we go. So converge means to join or come together. And diverge means to go away, kind of like in the divergent series. It's the people that don't fit in, right? So diverge means they go away. Converge means they converge and come together. So when we talk about algebra 2 and sequences and series, sequences or series can either converge to one number, or they can diverge and go off to infinity or negative infinity. Okay? So true or false? A divergent infinite series. Whew. Divergent, meaning that it doesn't come together, it goes away. If it's infinite, what does that mean? Keeps going forever. A divergent infinite series does not have a sum. It goes on forever. Would you agree with that? If two rivers converge, they do not meet. An infinite series that has a sum is convergent. Well, that's true, but we have to discuss how that can be. How can a series, remember what a series is? It's something that you add the same number or you multiply the same number and you forever. Okay, let's see what that would look like. Okay, let's try one, should we? So let's try this one. Is this a convergent or a divergent infinite series? Thanks for turning that off. Appreciate that. Convergent or divergent? Does it go on forever, or does it actually converge to a number? Does it come together? It goes on forever, right? Okay. How about this one? Goes on forever, okay? The first one was what kind, arithmetic or geometric? Arithmetic. How about the second one, arithmetic or geometric? Geometric. So in these two cases, there is no divergent situation. I'm sorry, they're both divergent. They don't converge to one number. We are going to look at some situations where you have an infinite number and it converges, an infinite sequence or series, and it actually converges to something. And so that does happen. But it only happens for geometric. Okay? Geometric series are the only ones that can converge, and we'll look at some of those in just a minute. Okay? So, let's stick with finite first. Okay? Finite means it has an end. And you should have a formula on your formula sheet. You should see it under the geometric. Your first formula, it says S sub n. Do you see that there? Okay? It is the same thing as what you see here, hopefully. Double check it. Is it the same thing? Look at your formula sheet. It should be exactly the same. Just so we can see here. Thanks, Cam. A sub 1. Brittany, put your head up, please. What is A sub 1? The first term. And what is R? The number how much you're multiplying by to get to the next one, the common ratio. And n is the number of terms, okay? So you have all these different things that we're going to need to fill out. N is the number of terms, R is common ratio, and A sub 1 is the first term, okay? So you have this formula to use to figure out what is the sum. So let's look at an example. Okay, now this one's kind of a basic example because we could probably just add them together. Remember how we did this last time? And couldn't I just add them together and figure out what the sum is? Okay, but let's use the formulas as practice because sometimes we have to use the formulas. So what's the first term? Okay, and again, why do I need that? Because it's in the formula. Okay. What other information in the formula do I need? What's R? How do I find the common ratio? How do I know that it's not arithmetic? By looking at it without even looking at the numbers really much at all. How can I tell instantly that it's got to be geometric? It's not arithmetic. The negatives. Negative, positive, negative, positive. When they alternate like that, aren't you throwing arithmetic out the window? Has to be geometric, or neither. How do I find the r? What do I do? What do I divide? Take two numbers that are next to each other in the sequence, or the series. I don't care which two. We'll pick 30 and negative 15. Doesn't matter. I could have just as easily have picked 480 and negative 240. It doesn't matter, as long as they're next to each other. And if I divide them, what do you get? Negative 2. So negative 2 is the r. That's the ratio. What other information do I need? Look at your formula. What other information do I need? N. What is N again? The number of terms. How many terms are there here? 1, 2, 3, 4, 5, 6. So what is N? 6. So I have everything I need. So let's use the formula and let's come up with what it would be. We're going to use the sum formula and we're going to plug it in. A sub 1 was negative 15. Parentheses 1 minus r to the n. You better put that negative in parentheses, folks. That's really important. Divided by 1 minus r. Now at this point, your calculator, it was going to ask you to do some simplification, but your calculator will do it right from this point. You can type it in just as you see it. But we're going to need to go to alpha y equals to put it in fractional form. Make sure you're using the negative signs and parentheses. So I want everybody to do it. Plug it in. Tell me what you get. And tell me what the sum of this series is. So 315 is the answer. If you didn't get 315, I have to say it's probably because you didn't put parentheses in the right spot, that you didn't use a negative sign. You might have used a subtraction sign or some other error. Okay? That was the cutest sneeze I've ever heard in my life. Oh my. Did your ears pop or anything? Like, that was so high. That was so cute. I don't even know how you do that. All right. Any questions about that? Okay. So when it's finite and you know what they are, you know the first and the last term, you can find r. You can just use the sum formula. The problem that we have to know is how many terms there are. And that's not always given to us. Okay? Sometimes we have to find that. So let's look at a situation where that might happen. So let's look at, I'm going to kind of create one here. All right, so let's look at this particular series. And I'm going to ask you, is this a convergent series or a divergent series? What do I mean by that? Is it getting closer and closer to one number, or is it getting kind of going off to infinity? Well, in this case, it's converging too, but what is it? Well, if I was to continue, you're right. That question really should be for an infinite series. If that 1 over 64 wasn't there, and it kept going forever, would it converge or diverge? What would it converge to? It would actually converge to 0. Isn't it getting smaller and 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 smaller forever? So in this case, it would converge to 0. But you're right, Noelle. It's finite. It ends at 164. How do I find the sum of it? Well, the formula for the sum, and I don't know how many terms there are, so I'll leave it as an n, is what's the formula? You have it there. It's your first term, which is 4, times 1 minus, well, I need r, don't I? How do I find r? So 2 divided by 4, or 1 divided by 2, so it's 1/2. We probably need to put, if it's a fraction, put it in its own set of parentheses, right? And in the top, that 1/2 is being raised to a power. The problem is that I don't know what that power is. Would you agree? I don't know what n is. I don't know how many terms there are. Well, there's a couple of different ways to do it. The shortcut way might just be, well, let's just keep dividing by 2 and multiplying by 1/2 until I get to 164. Would that work for you? That's kind of the short way. I could say, okay, this would be 1/2. What would the next number be? 1/2 divided by 2 is 1/4. Again, 1/8. My point is that we could do that. Would you agree? Keep going. Okay. But there's another way. I can use a sequence formula to figure it out. Remember how we did this with the arithmetic ones? We're going to do it with the geometric ones as well. We're trying to figure out 1/64 is 4 times r to the nth minus 1 power. Isn't that the formula for geometric? Do you see it there? What's r? 1/2. How do I solve this for n? Do I multiply the 4 times the 1/2? Never. Why can I not multiply the 4 times the 1/2? Because 1 has an exponent and 1 does not. So how do I get n by itself? Not yet. What do I have to do to solve this for n? Figure out how many terms there are. Divide by 4 to get rid of the 4. If I divide by 4, what is 1/64 divided by 4? One over 256? I have to solve this for n. Do I know how to do that yet? We don't know how to do that, do we? We would actually have to take the log of both sides, which we haven't done yet. This is not something that's easily finished yet. So I think the only way that we would know how to figure out to solve for n is to actually count out the terms. Okay? So let's go ahead and go up here and do that. Okay? This is a little bit beyond our scope at this point. So 1/8 times 1/2 is going to be 1/16. And then after that, we're going to keep going times 1/2. Sorry, 1/64, right? Can't type it in right. 1/64 times 1/2. 1/16 times 1/2, guys. 1/16, good grief, 16 times 1/2. That's going to be 1/32. And then after 1/32, what's 1/32 times 1/2? That's when you get 1/64. So I found the missing terms where the dot, dot, dot would go. And then how would I just count, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So what's n? 9. Okay? And now it's just a matter of plugging it in and finding it. Okay? So we'll go ahead and do that. We'll find that sum. I'm going to use 0.5 if that's okay with you guys, rather than put the parentheses in fractions, but it doesn't really matter. And I get my sum here to be 7.98, approximately. Thank you. Lorenzo, Miss Connolly wants to see you by the gym doors. Okay. So again, if you're missing some terms, for our purposes, we'll just figure out what those missing terms are, and then we'll find the sum. Okay? So if it's finite, we know what formula to use. It's a matter of plugging in the first term, finding r, and the number of terms. It becomes a little harder when we talk about an infinite series. Okay? Do infinite series have sums? Some do, some don't. There's a different formula for it. You should see it on your formula sheet. Do you? It's the last one. And I think it has an infinite at the bottom of it, doesn't it? I think it says S and then an infinity sign down here. Does it? That looks funny. I can't even write it that thin. But it should look like that. I happen to think this formula is a heck of a lot easier, don't you? It looks easier to use than the one above it. Okay. So we actually say that if it's an infinite series, it doesn't actually equal it. It converges or gets closer and closer and closer to a number. It converges to a number. Okay? It's approximately equal to this particular number. So let's look at an example. Let's look at this series. Okay? 1/2, 3/4, 9/8, plus, plus, plus. Let's just, don't have to write this one down. Let's just decide whether or not it converges or whether or not it diverges. And if it does converge, can we find the sum? How do we decide if it converges or diverges? Is it getting closer and closer and closer to a number? Well, let's find the common ratio. What's 3/4 divided by 1/2? Let's try it. So 0.75 divided by 0.5. Let's try with the second two. 9/8 divided by 3/4. Do I get 1.5 in each case? So isn't 1.5 the R? Okay. All right. So what's the sum? Well, what's the sum? It's an infinite series, so we know what formula we're using. It has a dot, dot, dot. So we're going to use that infinite sum formula. We know what R is. We have the first term over 1 minus R. And I'm just going to put a 0.5 at the top. It's the same thing as 1/2. Plug that in and tell me what it is. Yeah. Is that right? I don't know if that's right. Yeah, you're right. You are right. Okay? So the sum, they would all add up to be -1. I don't think that, hang on a second. I'm looking at that for a minute. That doesn't make sense. If I added them up, would they be -1? I think it might diverge. Let's see. Does it diverge? You mind if I check it real quick? 9/8 plus 3/4 plus 1/2. Yeah, I don't think this is right. Can I tell you why? So if I sit back and I look at this, I kind of skimmed over an important question. Doesn't this look like it continues to get bigger and bigger? Right? And why does the sum equaling -1 make no sense? Because that would be getting smaller, right? Negative, you're getting closer to a negative number. Do I have any negative numbers in my series at all? Okay, so this is kind of questionable. Okay, I'm putting a question mark here. I kind of skipped over an important thing. I have to decide whether it converges or diverges first. Because if it diverges, there's no sum. Okay, sometimes they have sums and sometimes they don't. How do I decide? I'm telling you that it's divergent. But how do I figure out? If the absolute value of R, which I found to be 1.5, is greater than 1, what does that mean? Let's look back at the formula. The absolute value, if it's greater than 1, does not have a finite sum. Did you see that? If my R is bigger than 1, it's divergent. So what can I say here? My R is bigger than 1, so what am I going to say? It diverges, and there is no sum. Okay? So that's important. Figure out the r, and if it's bigger than 1, then we can't use this formula. This formula is only used if my r is less than 1. If it's a fraction. Okay? So let's look at one where we can find. Okay? Let's look at a couple of examples, and let's decide whether or not it has a sum or not. So this is one you want to write in your notes. Okay? You want to decide, does it have a sum, yes or no? So I want you to look at the summation notation and decide, does it look like the formula that we know? It's telling us it's geometric. And if you look at the explicit formula for the geometric formula, it looks like this. Do you agree? Isn't that the explicit formula for a geometric? Well, where's the n minus 1? I have 1/5 and an n. I kind of showed this to you a couple of class periods ago, if you remember. But I want you to tell me why this is the same thing. Why are those two the exact same thing? They are. Has to do with exponents and bases. Are the bases the same? They're both 1/5. If the bases are the same, what do I do with their exponents? I add them. What is the exponent for the first one? 1. So what is 1 plus n minus 1? Isn't it just n? So isn't that just what I started with? Okay, so that they are equivalent, right? Jackie, let me give you what you need to do for work. So what is my first term in my sequence, or my series? The first term would be 1/5. What is the r? 1/5. You'll also have to do some problems from your review, okay? Wait, thank you. So what is r? You just told me. What's r? Hello. What's r? 1/5. Is that bigger than 1? What 1 divided by 5? What is r? What is 1/5? Tell it to me. What is 1/5? What's 1/5? 0.2. So can it have a sum? Yeah. Yes. Yeah. Okay. Yeah. It has a sum because 1/5 is not bigger than 1. It's smaller than 1. So let's find the sum. I can't plug this into my calculator. I can't put an infinity in my calculator. The summation function on the calculator won't work. So in this case, I have to use the formula. The formula is your first term divided by 1 minus r. Do you agree? That is the formula. So what is the first term? 1/5, or 0.2 if you want to write it that way. And what is r? 1/5, or 0.2 if you want to write it that way. So 0.2 divided by 1 minus 0.2. So 0.2 divided by 1 minus 0.2. And you should get 1/4 or 0.25. So that's what the sum, if I continue to add this forever and ever and ever and ever, 1/5, 1/5, and keep going, you would get to 1/4. So it does have some infinite series, if this goes to infinity, some infinite series do have a sum, but only if the r is less than 1. Okay? That's the key here. So I want you to go ahead and try some problems with this. And then let's see how well we do. So let me give you some problems to work on with geometric series. Some will be finite, some will be infinite. And I want you to do problems 10 through 15. Okay? So just 10 through 15. And Joyce, would you tell Jackie that as well? Just 10 through 15, okay? So 10 through 15 here, guys. Brendan, 10 through 15. You start with number 10. Shh. I want you to decide if it's arithmetic or geometric. And then you have to evaluate for 9 terms. Is this arithmetic or geometric? Arithmetic. So you're going to use the arithmetic formula. So they're not all geometric. Okay? So number 10 is arithmetic. You're adding 3 each time. So you're going to use the arithmetic formula and find the sum of the first 9 terms. Okay? The arithmetic formula is going to be 9 divided by 2 times the first term plus the last term. Got to find the last term. So we'll have to go out and find it, okay? And then tell me what that answer would be. So some are arithmetic, some are geometric. They're combined there. So when you are done with problems 10 through 15 all, you're going to be doing, turn it in obviously, and then you're going to work on more of your released SOL. We stopped at number 11, so you are going to pick up with problem 12. So on the released SOL from 2015, which is this year, you're going to do problems 12 through 25, all. And make sure that you're showing work. Okay, so that'll be your homework. And then obviously this classwork you're going to turn in separately, okay?